Hi, I'm Brandon,
And I'm Lucas.
and we're from 9 through 7, and we're going to explain our early season robot. So, the basic premise of this bot was basically a lot of inspiration from TNTN. Since we're seniors, we started our season pretty late. So, even though it was really long after Mall of America, we still knew that we wanted to do something interesting for this game. So this bot was mainly designed for skills, which is not very good, but we'll talk about that later. So I'll start off with the drive. So we ran 480 on 3.25 inch wheels, 48 to 60. We laid down our 48s with the hubs intact just to keep the spacing, and used the low strength 62s to also maintain the spacing. And then we used standoff structural screw joints to also brace the drive. The drive is 27 with a full C channel across and a full high strength axle across with bracings to like our funnels. And yeah, this drive was pretty good considering how fat the bot was as well. Running a center traction was nice for prog to not like drift as much and also not get pushed off the goal. And we also did side panels, since with the new plastic rules, we had to split up the side panels into two pieces. This wasn't like that big of a deal since it was just all catted out. And then the sleds are just simply catted to the wheel. And yeah, then we also had a motor stack in the back, since we also wanted to fit two odometry pods with like pretty minimal offset. So the vertical isn't offset at all. The horizontal is offset by 0.5, but that's just because of the rotation sensor. And we also ran, as you can see, leaf spring from 265 for E-Echo from their last year bot. So having this in one piece really helped us save plastic as well. And then I'll go on to the intake. So the basic design of this bot is a C bot and it's under goal as well. The ramp shape is basically like this, up to the motor stack and down. You can maybe see the ramp through here. It goes up. And then from the back. And the idea of this two-sided intake was, since we saw that TNTN's robot could only score from the front, it wasn't as optimal since you would have to turn around every time you wanted to match load. So we had this second intake in the back with the match loader, since that would just be faster. And we also thought like in skills with some motions, we wouldn't have to do like 180-degree turns. So that was the basic idea. But what made this weird was we had to split up our intake wattage, since there's already 6 motors on the drive. We had to split it up into 5.5 for the front, 5.5 for the back, and 11 watt for the top stage, since we need a logic system to basically not jam the balls. This has a capacity of 9, around like 3 in each section of the intake. And we use like a sensor for that, we'll explain later. So having this second control, or this separate stage control, was both good and bad, because I would say that being able to like smoothly control all the stages was good, but the lack of torque from the 5.5s was pretty bad. I'll go into more depth on each stage. So yeah, thank you. So all of the 5.5s were the front one is geared to 600 with this like canted gearbox. It's not canted, but like there's a bearing on this side, and there's a spacer, or there's a tapped spacer as a collar with a capped axle to prevent the gear from sliding out. So this is 600. It went into this roller. This is pre-catted. It was kind of weird, but we figured it would work. It's basically like a flex wheel with punctured holes and zip ties shoved through those holes, 6 on each spoke. And then latex tubes are like friction fit onto the zip ties. This is a really weird roller, but it made sense for us to do since we didn't want to have like any crazy like funneling things for the balls. So what happened is like the ball would basically go into the softer latex instead of the stiffer flex wheels. This stage, we cut the spokes around the flex wheels just to get it, help it go over the cross brace. You can see we are also dremeled out the cross brace to have like foam, because we had occasional issues where the ball like got some weird orientation with jam. And then this was also chained down to our front roller, which was really wide as a band roller. We decided to do hard mounted band rollers because we noticed from Mall of America, a lot of the Reguan robots and stuff, when they had flex wheels, if they drove super fast into the balls, even though the flex wheels have a lot of grip, it would like push away the balls instead of trying to intake them. So we thought this would be good, but I think this is still kind of bad to not put it on floating because it made our logo like pretty bad. So yeah. And then, oh, I forgot to mention, but all of the intake is single lane instead of 2-lane. And the reason we did this is because there's physically no way to fit like anything else like electronics and stuff onto the robot without it being single lane. So because of this, we had to kind of make like super steep funnels. There's like these U channels in the front. These ones have like holes for like a drilled standoff for like the wall rider and the aligner. And the back is the same geometry. The C channels are cut a little bit for the match loader, but it's essentially the same. These are kind of bad though, because we couldn't tune the funneling to be that great with 2 balls and it would jam a lot. So I would still suggest to do 2-lane. Yeah, all of this is 1-to-1 for the front stage. Now for the back stage. The back stage we had to tune and play around with for match loading speed. But this is 800, 48, this is like a half cut 48 to a 12 tooth. The pulley is there to just keep the gear on. And then we did a flex wheel stage for this one since it would compress into the 84 tooth stage for the scoring stage. And the cut flex wheel in the middle is just to help grip on the outer edge of the balls. And the same thing on the bottom, just a 1-to-1 band roller. It was a little bit less wide and it was a little bit worse since the towers for the entire like intake structure was mounted in the back. So since this wasn't as wide, we had issues during skills like with our part clear. The balls would basically get like caught on like the sprockets and between like the ramp of the park barrier, and it would sometimes jam, so that was kind of bad. And then lastly, for the scoring stage, we wanted to dedicate an 11 watt since we knew this would have the most strain pushing up all the balls into the goal. So it's directly connected to this axle of a shaved 84 tooth with the bands, and this would basically help loop balls from the front stage and balls from the back stage up. And then this went to smaller IQ sprocket rollers. I forgot the tooth, 24 tooth, I think. So this one is also at 600, and then this one instead is geared to 900 onto these flex wheels. And then the last roller, trying to open the hood, which is like a stiffer roller. Thanks a lot to Charles from 88NA for dropping his Google album. It helped us tune a lot, so yeah. And this is the hood. It's just on a piston. It basically helps keep like the balls in. And then there's a long mesh roof. The pistons are hard mounted here as 3-inch. It probably would have been better to have the pistons push down since pistons have more force when they're extending due to the greater like area within the pistons. But since like there's a big lack of space from having like all of these intake stages, we just simply couldn't. And since we did used to have plastic catted as like a cage for the side panels, but we realized that we physically couldn't have like any other pieces left. So instead we just did like a drilled standoff braced by this like cut 5 wide for the pistons, and that worked fine. The pistons were also nice since they helped naturally funnel the balls. It was kind of scuffed, but it basically like rode along the pistons and the valve and stuff. And then these standoffs are to prevent with the flex wheel stage being stiffer from like shooting the balls out. And then this entire structure, the only actual hard mounted was this half cut to a base pivot here. But since we knew from watching 10 Tons reveal, we wanted the hood structure to be parallel to basically maintain like how the hood opened in relation to the ball. So because of this, we have these steel cables. It means like the whole hood pivot can like pivot back, but it makes this like a 4-bar structure essentially. And these bands tension it forward. We chose steel cable because we didn't want any change in tension from like paracord or like wearing out over time. So that was nice. And I would say this is kind of still bad because of our wing being able to like fully comply backwards. But yeah, we'll explain that later. And then basically how we used the steel wire was using shaft collars to mount it, since you can't use like the mounting brackets and stuff that steel wire comes with legally. I guess I'll go on to explain the match loader since that goes with the intake. Trying to deploy it. Yeah, we have the intake idle just to help keep like the last ball in. basically the match loader, oh wait, actually it's kind of loud. Yeah, at some point, yeah, okay. So the match loader is just these half cuts. The piston is mounted onto like this plastic structure that goes to the triangle C channels. And then the half cuts, what we did kind of unique on our match loader is, even though it's just a basic like pivot overclock mechanism, we had funnels on the match loader. So what this allowed us to do was to essentially funnel into the match loader, but also to fully touch the wall. So every time in auto and in skills, we would essentially realign onto the wall, which is super nice. And you see they just slide into the bot. Other than that, the structure is like pretty basic. It's just a high strength axle, but something weird we kind of had to do, and you can kind of see here, it's kind of loose, but we had to have this like super long half cut. It's a bit bent from our comp yesterday. So yeah, if you want to retract it, you can see that this bot is super long, and since this is a 32 long drive base and we have our front roller and our liner needs to kind of be long to have like a good funneling range onto the goal, we were pretty limited in our backspace. Like the front aligner to the end of the drive was basically 35 holes. So we only had like half an inch to work with. So getting this to fit in size was super annoying without touching the rollers. And it was definitely why like our match loader wasn't the greatest. And we had a lot of issues at our comp with tuning it and stuff. So that's why it's on like these zip ties and like mesh as spacers instead of pillow blocks, because the pillow blocks are like a little bit too tall. The standoffs are just there to prevent side-to-side rolling in the match loader. We had to change the pivot around in the hole at like the comp, but it still wasn't the greatest since we didn't have like dedicated funnels to help the balls like stop rolling from side to side. I think that's it for the intake. I'll go on to the wing, which is probably the most unique part of this bot. So if you want to drop the tilter. So one of the things with undergoal is that we knew we wanted to maintain the undergoal while still having like a good up and down wing to like pick which balls we wanted to score from the goal. So what we did is we catted a wing to be on this like linear slide where the entire piston and wing move on this pivot to a vertical position when the tilter's up, but it completely folds within the profile of the bot so we don't like scratch on the walls and stuff and still have like the versatility to go under the goal. So what it is just a drilled standoff rail. They have a Dremeled half cut as like a sliding base for the pillow block. And then we drilled through the pillow block to run a steel cable across this pulley pivot and down to the liner. And the basic logic behind this is that whatever linear distance this changes by needs to change from this point to whatever other point on like the robot, which happened to be like the aligner for us. So this latex tubing basically retracted it, and then every time that it tilted up, the cable would just pull against the tubing. This secondary tubing was just to maintain the tension. And we also had this like plate metal guard since we had worries of like the cable slipping out of the pulley or something during the match. So yeah, it basically went up like this. You can tilt it. And we also have it macroed to auto go up just for like scoring and moving around the goal. If you want to drop it. This was like the height it was at. And we added on a second standoff at the comp just to try and make it like a little bit better. But I would say it was still pretty bad because every time it tried to push balls when there were like multiple balls or if another wing was against us, this entire structure basically could just pivot back. And we can maybe drop a Google album later where we like have like a standoff, like a bent standoff aligner to try and like mitigate this issue of getting like pushed off the goal. But it really did not help because you can just see every time the bot like jives weird or another team pushes us, it just the entire thing bends. And not having a rigid wing just meant our D-score was super limited. So yeah. And then some last things that we did. So inertial mount was above the drive on these 4 rubber links. That was nice to help like reduce like the vibrations and stuff. We also have I don't know if it's hard to see, but we have a odom retract piston since we wanted to try for skills and we still wanted like to have tracking. You can see it's up right now from the drive, but when you turn off the program, it drops down. So that just helped with barrier cross. And a lot of other smaller things is that we used a lot of nylon standoffs like everywhere, since we knew we would have like a lot of tech for prog, like a bunch of sensor use, which we'll explain later, all of the pistons on the bot, like all of the wings, the tilter, the hood, the match loader, and as well all of the strong braces we needed. Like our front liner, since it had to make space for the front roller, it had to be like a super thin bracing point. We actually bent a lot of high strength axles during testing from running auto, so we had to do some weird stuff like making a lot of the drill holes smaller. So you can see like from the CNC hole, there's dedicated screw holes here, but when we had those before, it would break. So instead, we moved those holes to be here, and we used the low profile high strength collar screws instead, which are M2.5, and just screwed those into the axle. So that basically helped move as much of the material into like the contact point. And then we also had to like bevel the corner on the goal, since we realized that like if the tip was like full and it like hit into the goal, a lot of the force would be like directed towards the center. And I think that's pretty much it for the mechanical side. Do you want to talk about the prog on the bot?
Yeah, so obviously we have odom, and like Brandon said before, we have the inertial and the pods that we talked about. We decided to use 2-inch just so that we can like save space, and they're mounted at the interesting 30-degree offset where you just snip off the
insert or whatever, yeah.
And then you get this nice 30-degree angle. We found that like maybe it helps. We didn't do like super concrete testing, but it seems to work pretty well. So yeah, we chose to do that. And in addition to that, we have these 4 distance sensors, which you may have noticed on the bot. They're here, and it's just on every one of the axes. And so we use these in order to like reset throughout the field, both in match and in skills, because obviously since the match loaders themselves are mounted on the top and they're like offset, we want to make sure that this set and the goal, since they're different, we want to be able to like have really accurate readings that we can like align correctly every single time. Because we saw in like a lot of other skills that if you misalign, or even in match auto, if you misalign, you miss the match loader, and like that's a lot of points. So we wanted to like just do everything we could in order to mitigate that. And we ran the same thing last year with these 4 distance sensors as well. One thing to note is we should probably mount them higher, as we realized that during testing that like if the ball is like somewhere outside of or like some distance away from it, it starts to detect it at the height that we have it here for the left and right ones. And so if you do plan on using these, definitely mount them higher so that they don't see the balls, since that messed up a lot of our readings. But other than that, I guess we used to use MCL, but for these distance sensors, we found that like just because the lighting in our garage isn't very good, and the lighting
single light
and the lightings at comps can also be very like it can vary a lot, and that in addition to just these distance sensors not being the most accurate resulted in a less than reliable MCL. And we felt that like especially this year, it mattered a lot less last year, but especially this year, having that like little bit of off could result in a really bad skills run. So instead we just use distance resets, which is why you may have seen in the video that all of our walls are backed in paper, because we have the metal field.
We have a metal field. We don't want to buy a plastic one, so this is like the polycarb. This is the plastic, and you can maybe see from last year, this is like the yellow from the goals and all the corners that we used. So
it's just like poster paper or any like white paper. It seems to work pretty well, and we've gotten pretty reliable results in like with the compared to like the plastic field. And so we've used that in match and skills this year, and that's resulted in pretty consistent autos. But other than that, for the match aspect, the only other sensor we use really for match is this one distance sensor that's like in between the scoring and the back intake. So
we're gonna show what
this is pretty similar to like the other bots, where you might see that like the distance sensor controls whether or not the scoring stage is running, and so it acts basically in the same way.
So you can see there's 4, and now the 5th, now the stop stage stops.
And so once that sensor detects that there's a blockage for like I think 200 milliseconds or something continuously, then it'll basically just stop running this. And we also use this for different state controls as well, like Brandon mentioned before, for the logic of it. And so this has been like semi-reliable, I would say. I guess it's like, I'm not sure if it's really like, it's probably both mechanical and programming, but
Yeah.
there's just a lot of like unreliability with this. First of all, you need to like have a certain amount of delay to determine whether or not you're getting noise from the sensor or you're getting accurate readings as to whether or not the ball is actually like blocking the distance sensor for those changes in logic states. But other than that, it's been pretty reliable, and we can see that like this helps us to control our outtake state primarily as well. And so if we have balls in every stage, it's going to outtake these first and then the ones in the front stage, and that just allows us to control that.
Yeah. The basic premise was that the back intake had to be prioritized with the scoring, since we can't have the front stage basically like fight the balls like in the back if it was like full. That was same for like outtake. It was really weird with outtake, since if we wanted to do it from the back, it had to be the back in the scoring, and then once it detected there was none from the distance sensor, then it would run this like scoring stage forward again, because the balls in the front stage are only controlled by this like last flexible roller, so the balls will just sit here, so it had to run forward again to get them out and down. But we found that was also like pretty bad for match. So for match we had like a different state where we used the front, where this stage would spin forward, this stage would spin backwards. Oh, holy stuff.
Okay, it's jamming.
Yeah, that's great. It's like, I'll just like pull the balls out. We'll explain later why the ramp makes an annoying issue. But yeah, basically it's a scuff on our controller, just the front scuff.
It's just a shift toggle.
Yeah, and the way it vibrates. So wind take, you can see now it idles there. So I can put like another one or maybe another. And then it's basically idea is just to spit it out the front. So yeah, even though we never really used this in match, since we also found out later during skills and during an auto, an issue with like the front aligner, since it's split into two pieces and we had this brace and the floating stage not, or the front stage, sorry, not being floating, the balls like couldn't end up really going out the front anyway. We still had this like in mind since it was just way too unreliable. I guess we can go on to all the issues with this bot. So you can see there with like the outtaking what was bad. And that was primarily just a major issue with like having the dual intake system and trying to split a ramp between two inputs to one output. So when the balls like try to outtake down, it catches a lot like on the peak of the ramp here. And the problem with tuning this is that you still need it to be stiff to like for the ball to be able to bridge the gap from the front to this like a dead zone space between all of the stages and then up. So that was one of the major issues with having dual intake, and as well being like having, again, as I said before, splitting up all the wattage into like 5.5s and 11 watt just made like the back intake really struggle with holding two balls at the same time. I don't know if we can, or yeah, this is the funneling. You can just see here, it just doesn't want to go up because it can't prioritize one or the other. And then as well, like match issues as well. Since this bot is relatively top heavy, like what the weight distribution is basically just these four motors, maybe like the motor stack and the brain. Since we needed space for our pods, you can see like it's a really hollow bot under the ramp, but that's just because we had to make space for like the lift and the balls to not hit the pods. But what this issue like really made, maybe you can demonstrate it, is just the bot like tipped a lot. Just every time our driver wanted to make any like quick movements, it was essentially just like a half a second delay because the bot would just be tipping back and forth. And that was just primarily because 480 has a super narrow contact patch, even though it's like a relatively long drive base with the 6 wheels. It's just super small, and a lot of the weight got concentrated up top. Like I could only put the solenoids like up here for all the pistons, since this like bot uses a lot of PSI from tilting up and down. You can see like the tank, even though it's like diagonal here under like the motors, it was still like decently top heavy as well. And then other annoying match issues was that since we had a front intake, our liner could like end up riding up. I don't know if I'll be able to show it, but like basically since it's on this angled part, it like likes to ride up. You can see like the tip's already bending, but yeah. So that was like annoying. And then as well, we found it during skills. Like this used to be like a full half cut. You know, just keep catching and like on the paper walls and stuff. So we had to like put wall riders. And overall, this bot was like kind of a pain in the ass to tune. So that's why I necessarily wouldn't recommend it. So, and yeah, even though the undergoal benefit was like super nice and we used it like a few times in matches where like teams would just be doubling us for, like, or doubling down on us like on one goal, we would just escape to like the other side to descore. It still proved like not super reliable and like consistent in use, especially since we spent way too long tuning this bot and like not enough driver practice. So
And it's just not worth the trade.
Yeah.
Like having like this.
yeah, the
compliant
super
wing
compliant wing, it was just really bad for
makes
match.
descoring like pretty much impossible for the driver under defense.
Yeah, and as well, another issue is since we have this like tilter design, we physically can't have like like an aligner onto the middle goal. So if you want to drop it, you can see that like, and we can also have like some autos maybe up. Just the bot, it can be anywhere like from like consistently off, even though we're resetting like everywhere. This position of the bot means that there's like pretty unreliable data from the distance sensors, so it wasn't like perfect every time, and with like the odom drifting as well. It was just super annoying, just like every time if the bot was like a little bit off from like the center of the goal, the balls just wouldn't score like onto the middle goal. And it was really bad in match as well, since our driver had like no way to accurately line it up. So yeah. And as well, another major drawback was even though we tried as like hard as we could to use all of this like weight saving hardware, like the standoffs and then these like HCU nuts from 7700R, shout out to them. The bot still ended up like being super heavy because of all the bracing we like had to do. It's like this high strength axle, like this one for all of the structure, the bottom drive one to like stiffen and torsion the drive. It was just like super heavy and we like couldn't really do anything about it because of also like all of the programming hardware and just how dense the like robot had to be. Like you can see the brain or the battery just has to be like in this like scuffed like area. So that was super annoying because it limited the acceleration of the bot. Like I think Lucas can testify the PID tuning was like pretty atrocious on this bot. So
yeah, worse than usual. But
yeah, it was not pretty bad. So that was an issue. And as well, like since we had to use stock VEX tractions because we didn't want like the inconsistency of making like a flex wheel traction, especially with like poly rules, it would have been more ideal to use like the easy wheel where it's like the plates of poly on either side of like a shaved gear. That way it like keeps the like 3-inch flex wheel consistent in diameter around instead of using like zip ties. We didn't want that inconsistency during prog with like the bot like bumping around and stuff. So the stock tractions pretty much did like nothing for us too much, even like with the entire weight of the bot. It was like still pretty easy to like shove off the goal. We maybe could have done like drop center, but I think that would have made like the tipping like a lot worse. So yeah. And as well, I just think there's too many like issues in CAD as well that we had. Just a lot of stuff not working out as they should, like in the actuality. Like the matchloader wasn't CADed for a reason because there's literally no way to figure out how to get it to retract in. Tuning like the hood spacing as well. Since 8889A had like custom plastic and stuff for their spacing, we had to figure out like really weird and scuff spacing, like drilling onto these like half cut flanges, and same on here to like offset the hood by some specific amount, and tuning like the roller compression and stuff just to get it right. I would say the bot still overall was as best as we could get it for this like C-bot design undergoal with like a dual intake as well to get rid of like the issue of turning around. But I think in general, this bot was still limited by basically everything had to go right for it to like work well. And I think that's pretty much it. Do you have anything else to add?
no, I think that's it. Yeah.
Yeah. If you guys have any questions about the bot, or if you want like to see like maybe videos of it like scoring and all the autos and stuff with it, since there was a lot of cool stuff we could do with this bot, like being able to rush under the goal for 6+3. And a lot of other like cool stuff during skill. Oh wait, I forgot to talk about the skills thing. I'll go grab it. Yeah. So one of the things we like noticed in skills was since we didn't have a wide enough intake to approach from the front and grab like the 6 like 1010G or 1010G does, we had to build like this wing thing What it is basically like it's a pivot. I take off this like back wall rider and just mount it, and then like the piston screws in here and like pushes down. It's just like
Yeah,
you can like
just,
shut. It's just like a wing.
comes down like this.
Yeah, and what happens is we cross this way, and then to prevent the balls, or we tried to prevent the balls from like rolling around, the wing would basically like catch it. And we also had like these rubber links to like put under as like compliant funnels to prevent the bot from like riding up onto the balls, even though it still did. So that was, I guess, kind of interesting, but it just shows like how bad the bot was with the single lane, with the issues of torque from the intake, which like all of these inconsistencies, especially just still not being able to pick up all six, like for our routing, which our routing was like trying to do max, but it wasn't really that close. So yeah, in theory, this bot was supposed to be like good, but in actuality and with now like how gameplay plays out with like descoring just being so crucial to the game, we just couldn't keep up with like the match. So yeah, I guess that's finally it. If you have any questions, leave them in the comments and we'll maybe answer them. So yeah.
See you at AZ6.
Yep.